So welcome to Electron Shikshalaya. You are watching PYQ of signal systems up to 2024-25. This is in the odd semester. So in this section we will see one log questions. Okay, that is a 16 mark questions. So classify the discrete time signal and systems with in details with some examples. This is a 16 mark question. So we have to classify the discrete time system and signals in details. Okay. So first of all, what is a discrete time signals? So discrete time signal that is x of n is a function of independent variable, that is an integer. Okay. So it is important to note that the discrete time signal is not defined at instant between the two successive samples. It is not defined between the two successive samples. That is the not defined for non-integer values of n. Okay. Next is the x of n is obtained by sampling the analog signal, that is x of a at t. This is the analog signal. If you sample this, x of n is a discrete time signal. That you can obtain the discrete time signal, okay, from the analog signal, that is xa of t. So where t is the sampling period. Okay. So this is a graphical representation of a discrete time signal. Okay. So at n equal to these are the integer values. You can say 0, 1, 2, 3. So at n equal to 0, it is 2, x of n equal to 2, n equal to 1, it is 1.5, likewise. Okay. So this is the discrete time signals. Okay. Next is some elementary discrete time signals are, suppose a unit sample sequence or unit impulse. Okay. So it is denoted as del of n is defined as this del of n equal to 1 for n equal to 0, and for n is not equal to 0, the del of n equal to 0. Okay. So the unit impulse signal is 0 everywhere, and at n equal to 0, the value is unity. So this is also known as a unit impulse. Okay. So this is the graphical representation of a unit sample sequence or unit impulse. So at 0, n equal to 0, the value is 1. At everywhere it is the value is 0. Okay. Next is a unit step signal. So it is denoted as u of n. So it is defined as u of n equal to 1 for n is greater than equal to 0, and 0 is authorized. Okay. So you can see at n equal to greater than equal to 0, the u of n value are 1, and for negative value the value is 0. Okay. So this is your unit step signal. Similarly, unit ramp signal, that is denoted as u r of n. Okay. So it is n for n is greater than equal to 0, and 0 is for n is less than 0. So you can see for values of this n, all the n values. So if u of 0, what is u of 0? It would be that would be 0. Okay. So u of 0 equals 0. Similarly, u of 1, it is 1. U of 2, it is 2. Likewise, 3, 4, 5, and likewise. Okay. So this is a unit ramp signal. Okay. Then exponential signal. So this is the sequence that is in the form of x of n, a to the power of n. Okay. So that a can be real or complex. For real values, I have not drawn the figure actually. So this is the real value. A can be real or complex. Okay. For complex values of a, that is written as a equal to r to the power e to the power j theta. Okay. And r and theta are the parameters. So x of n can be expressed as r to the power of n for that is the x complex value signal. Okay. So it is r to the power equal to cos theta and plus sin theta. Okay. So this is the exponential signal. These are all elementary or standard discrete time signals. So the question asks for classification of discrete time signal. You have to classify the discrete time signal. Okay. So you can start your discussion from this point also. Okay. So classification of discrete time signal. So energy signal and power signal. Okay. So energy signal x of n is defined as, this is the formula for finding out the x of n. Energy of x of n. X of n is a discrete time signal. Okay. So the energy equal to finite, then it is called the energy signal. For energy signal, the power is average power, that will be equal to 0. Okay. So in this case, you can see the average power of a discrete time signal equal to this one. Okay. This limit tends to infinity 1 upon n to n plus 1. That summation of n is from minus n to plus n x n square. Okay. So you can see the energy signal, the energy you can define for the interval minus n to plus n, this one. So we can express the energy as E of n. Okay. Limit n tends to infinity. Okay. Then also we can write. Okay. So average power equal to this one. Okay. So if energy is finite and power equal to 0, in this case energy is just the energy signal in which the energy is finite and power is 0. Okay. Similarly, for power signal, the power should be finite actually, finite or infinite. What is in most cases the power average power is finite if we that signal is called that power signal. So you can see there are conditions for energy signal the first condition is there the energy should finite, so it is 0 to infinity, and the second condition is this power equal to 0. This is the energy signal. If these two conditions are satisfied, then the signal is called energy signal. For power signal, you can write down this power equal to finite. So this power will be finite. And second case is your energy is infinity. Okay, the energy is your infinite. Okay, then the signal is for the power signal. Okay. Next is one is a periodic versus non-aperiodic signal. Periodic and aperiodic signal. A discrete time signal is said to be periodic. The period is your n, so which is greater than 0 if and only if x of n equal to x of n plus n, where n is the period of the signal. Okay. Similarly, it is the n is the smallest value of n for which the condition of periodicity exists. It is called fundamental period. Okay. The discrete time signal x of n is said to be aperiodic if x of n is not equal to x of n plus n. Okay. So this is the periodic and aperiodic signals. Okay. So then symmetric and anti-symmetric signal. Symmetric is the odd signal, anti-symmetric is a symmetric is the even signal, anti-symmetric is the odd signal. A discrete time signal is said to be symmetric or even signal if it satisfies the condition x of minus n equal to x of n. Then it is called the even signal or symmetric signal. If x of n, that is anti-symmetric or odd if x of minus n equal to minus of x of n for all n, then it is called the anti-symmetric or symmetric. We can draw the diagram also. Okay. Next is your discrete time system. So we have classified the discrete time signal, then the discrete time system. So discrete time system is a system that operates on the discrete time signal. Okay, that is the input is called input or excitation, and according to some rules, it will produce another discrete time signal. The output is called output or response of the system. Okay. So you can see x of n is transformed by the signal that is to the y of n. The relationship between x of n and y of n equal to y of n equal to transformation of x of n. So at the discrete time system, it will operate on the discrete time signal that is x of n, and it will produce the output or response that is y of n. Okay. Now the T is the transformation. Okay. So this is the x of n, which is called the input signal on excitation. Then according to some pre-described operation, it will do some manipulation of this discrete time signal. Then it will produce some output. That is the output or response of the system. Okay. So let us see how it is classified. The classification of discrete time systems. Okay, so first one is the static versus dynamic systems. A discrete time system is called static or memoryless if the output at any instant of time, that is n, depends on most of the input sample at the same time, but not the future or past values of the input sample. Then it is called the static system or memoryless. Okay. Only depends upon the at that time, input sample at the same time. Okay. Then if not, the past and future sample of the input. Okay. If the system depends on the past and future samples, then it is called the dynamic system and to have the memory. So the system is, you can see there the examples are there. So in this case, this system you can see these are the static systems. Okay, because it depends upon you can see n is there. Okay, in this case there is a n. Okay, so n is there, n is there. Okay, so that is the same present input that depends upon the present input. So there is n, similarly n x of n, that is the present input. So it depends upon the present input. That is why this system is called the static system or memory system. Similarly, if the system are the means with a memory, if it depends on the past, you can see past or present. In this case, it depends upon the past values of the input. That is why the system is called the dynamic system. Okay. So the time invariant versus time variant system. So you can see what is time invariant and time that is the a system is called time invariant if the output you can see if the output input output characteristics do not change with time. Okay. So a relaxed system is called time invariant or shift invariant if x of n is transformed into y of n. So this is the condition x of n minus k transformation is y of n minus k. For every input signal x of n, every time shift k. Okay. So let us check this. So to test the system, if it is time invariant or not, first apply x of n and that produces the output y of n. Then delay the input by k samples and recombine the output is this one. Okay. So if y of n comma k is equal to y of n minus k, then the system is time invariant. If y of n comma k is not equal to y of n minus k, the system is time variant. Okay. So how to find out y of n minus k? So you can delay the input wherever there is input, delay by k samples, delay by k samples. Then you can find out the y of n minus k. Okay, how to find out y of n minus k? Replace the n in this equation by n minus k. Okay. Then if these two are equal, then it is time variant invariant. If these two are not equal, then it is time variant. Okay. So this is how you can test whether system is time invariant or time invariant. This is also called the shift invariant or shift variant. Okay. Next, whether linear versus non-linear. So you can see a linear system will satisfy the superposition theorem. So what is superposition theorem? So it requires the response of the system to the weighted sum of the signals equal to the individual. You can see corresponding weighted sum of the responses of the system to each individual input signal. Then it is called the linear system. Okay. So a relaxed system is linear. You can see these are the individual input signals. Okay. Then you take the transformation of the individual input signal. This is an individual input signal. This is also individual input signal. Then you multiply. This is the weighted. So this is the weights. So then multiply with A1, A2. Okay. Similarly, this is the response of the weighted sum of the signal. Okay. These are the individual responses. If this is equal to this one, then the system is linear system. Okay. Just replace if that is equation of x of n, okay, then y of n equal to something like n into x of n. Then first replace this x of n by a1 x1 of n plus a2 x of n. Then find out the equation. Next figure, then replace x by x1 of n, then multiply with a1. Then replace x with x2 of n, then multiply with a2. If both are equal, then the system is called the linear system. If both are not equal, then system is non-linear systems. Okay. So these are the constants, A1 and A2 are the constants. Similarly, causal versus non-causal systems. So a system is called causal if the output of the system, that is y of n, depends on the present and past, but it does not depend on the future. Future means x of n plus 1. These are the future input samples. But it depends upon the past and present. Then it is the causal systems. If it depends upon the x of n plus 1, these are the future values of input. Then it is called the these are the causal. So it depends upon the present and past values of the inputs. Okay. So if it depends upon the future value, then it is a non-causal system. Okay. You can see that the system output depends not only on the present and past, but also on the future inputs. If it depends upon the future input, then the system is called the non-causal system. Means if x of n plus x of n minus 1, it is the causal system. If x of n, y of n equal to x of n plus x of n plus 1. This is the non-causal system. Okay, because it depends upon the future values of the inputs. Okay. Next is the last one is the stable versus non-unstable system. So for stable versus unstable system, you have to apply some bounded input signal. Okay, that produces if it produces the bounded output, that is the BPUT, bounded input, bounded output. For every bounded input signal, if it produces the bounded output, then it is called the stable systems. Okay, you can see what is bounded actually. Bounded means that should be finite. Okay, that's x of n, y of n, both should be finite. Okay. So you can see this is the for stable system we are applying bounded input signal. If it is a stable system, it will produce the bounded output, means it is the finite values of the output. Okay, that is the thing. Amplitude should finite. Okay. Similarly, for on system that is unbounded means the value is infinity. The amplitude will be infinity for some instant of time or every instant of time that value is infinity. Then it is called the unstable system. If we apply the, but provided you have to apply the bounded input signal only. Okay. So this is the stable versus non-stable, unstable systems. Okay. So these are the classification of means discrete time signals, then discrete time system. This is 16 mark questions. Okay. So these are our references. Okay. Thank you for watching this video. If you have any doubt, you can ask me in the comment section. Thank you all. Okay. Have a nice day.